Now, let us discuss the geometrical interpretation of their derivative. So, for this first step, what we need to do is consider a function y is equal to f of x. Step 2, let us draw the graph of y is equal to fx in the xy plane. So, now let us draw the graph of this one. Y is equal to fx. Now, this is the y-axis, this is the x-axis. Suppose the graph of this one, y is equal to fx, is like this. Now, what we need to do is, now next step, you draw a line which cut this graph at 2 points. One is at point P and another one is at point Q. Let us take the coordinate of this point P be x plus x comma y, and the coordinate of Q be x plus delta x, y plus delta y. Now, next step, and let the angle made by this line PQ with respect to the x-axis be theta. Now, next step, let us draw a tangent at this point P. So, suppose the tangent at this point P be this one. Tangent is nothing but is a straight line which touches the given curve at a single point. In this case, it touched the given curve at point P. So, now let the angle made by this tangent mark this point T here. This is R here. Now, let the angle made by this tangent at P, the tangent TPR at P be psi. So, now, after taking the coordinate of this one cube as x plus delta xy plus delta y, note that this coordinate here, this point Q here, it can lie on the left side of point P also if delta x is negative. If it is positive, so it will lie to the right side of Q, or right side of P. Now, let us find out what will be the equation of this line PQ. Now, line PQ is a line which passes through two given points, xy and x plus delta xy plus delta y. So, therefore, what is the equation of the line PQ passing through the points P having coordinate xy and Q having coordinate x plus delta x, y plus delta y is given by y, I'll take this one capital Y minus y1, that is small y, which is equal to y2, in this case this one is y2, y plus delta y minus y1, which is y, divided by x1 or x2 plus x1. x2 is this one, so it will be x plus delta x minus x into x minus x1. x1 means x here. Using the formula equation of the line which passes through point x1 y1 and x2 y2 is given by the formula y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. So, by applying this formula, so we can find out the equation of the line PQ. Now, this one and this can be cancelled. X and minus x also can be cancelled. Then after that, it reduces to y minus y is equal to delta y by delta x into x minus x, which is of the form y minus y1 is equal to m into x minus x1, where m here represents the slope of the line. So, now here in this case, name this as equation 1. In this case, slope of the line PQ is delta y by delta x. So, this is the slope of the line PQ because this equation 1 represents the equation of the line PQ. And then since this one is of the form y minus y1 is equal to m into x minus x1, where m represents the slope of the line, so delta y delta x will be the slope of the line PQ. Now, but we know that tan theta represent the slope of the line PQ, where this theta is the angle made by the line PQ with respect to the x-axis. Okay. So these things, you just recall back all these things from class 11 and class 11 topics on the straight line. Okay, because tan theta, if a straight line makes an angle theta with respect to the x-axis, then tan theta will represent the slope of that line. So now here we have tan theta is a slope of this line PQ. So in that case, this will imply that tan theta is equal to delta y by delta x. Name this as equation 2. Because both both tan theta and delta x and delta y represent the slope of the same line PQ. Now let us see, by letting Q approaches P, along the curve indefinitely close to P. Close to P. That means by letting Q tends to P, move towards P or approaches P, and as it come closer and closer towards P, then in this case delta x will tends to 0. So this is possible only if delta x tends to 0. So if Q, if this point Q approaches this point P, from this figure you can see if this point Q approaches P, then this delta x mass approaches 0, because it will be possible only if delta x approaches 0 or approximately equal to 0. So now by letting delta x tend to 0, then let us see what will be this line now. If this point Q now approaches this point P or come closer and closer towards P or coincide with P, then in that case this line PQ will almost coincide with this line TPR, which is a tangent at this point P. Then in that case this angle theta also, by letting this Q approaches P, then you can see that if you approach it towards P, then it will coincide with this line TPR, and then this angle theta here also will tends towards this angle psi here. So indefinite, then delta x tend to 0. So in this case, line PQ will tends to this line, will coincide with the line TPR, which is a tangent at P, and then this angle theta also made by the line PQ, this angle theta made by the line PQ also will tends towards this angle psi, tends towards psi. Now from this equation 2, that is tan theta is equal to delta y delta x. Now from 2, limit delta x tends to 0, delta x delta y is equal to tan psi, because if delta x tend to 0, then in that case theta will tends to psi. So you replace that one by psi, and what is the formula for this one? Limit delta x tend to 0, delta x delta y, it is defined as delta, or it is defined as dy dx. We have done in the I've given you the definition of derivative as a rate measurer. limit delta x tend to 0, delta x delta y represent the derivative of y with respect to x, that is dy dx is equal to tan psi. Hence, this value of the derivative, hence, we can see from here that, hence dy dx or the derivative of y with respect to x is the slope of the line it represents the, hence dy dx derivative of y with respect to x is the tangent of the inclination of the tangent line TPR at the point P on the curve y is equal to f of x, or sometimes it is known as a slope or gradient, or it is also called as, that means dy dx is also known as the slope or gradient of the tangent line at a point P on the curve y is equal to f of x. So this one is the geometrical interpretation of the derivative of y with respect to x. So you can see from here, the first step what you need to do, you consider a function, draw the graph of that function, then take a line which cuts this given curve at 2 points A, P and Q. Now suppose the coordinate of P is xy and the coordinate of Q is x plus delta x, y plus delta y. Then letting this point Q approaches this P, that will be possible only if delta x tend to 0 or approaches 0. So in that case, this line PQ will almost coincide with this tangent at P, that is TPR. So initially the angle made by the tangent line with respect to the x-axis is theta, but by letting delta x tend to 0 or point Q approaches P, then this theta will coincide with this psi with the angle made by the line TPR. So using this properties and also the equation of the line PQ which passes through the point P and Q, we are able to show that finally the derivative of y with respect to x is nothing but it is the inclination of the tangent line TPR at the point P on the curve y is equal to fx, or slope or gradient of the tangent line at the point P on a curve y is equal to fx. I hope with this explanation now it is clear regarding the geometrical interpretation of the derivative dy dx.